Here's how to create a simulation to estimate the probability that when you roll 2 die that the sum is 7. We're going to start off by putting the numbers 1 through 10,000 in column A to represent 10,000 rolls. You could start here and go down. It turns out that it's easier if you go to the name box and type N 10,000 and it pops right to A 10,000. Here you can put then 10,000, hit enter, and then above it you can say equals the cell below it, -1. And then we can copy this up till we get to cell A1. So we're almost at the top. $200, $100, and there we go, and let go. So now we have the numbers 1 through 10,000 in column A. Let's click on row 1, right click, and that will insert a row, and let's put a label. The label here is the roll number. It's just a text. Now here we're going to put the roll of the first die. So we'll put die 1, just a text, and here in order for it to randomly select an integer between 1 and 6 we type equals rand between open parenthesis 1 comma 6 close parenthesis. That will give us a randomly selected integer between 1 and 6 including 1 and 6. Here it says 5. Every time you press F9 it will recalculate a new roll of the die. So in order for this to work you must have tools, add-ins, and both of these analysis tool packs checked. So in this column we're going to put it label die 2, and here we want the same thing as here, exact same thing. We can just drag it, copy it to the right. Now we have a 3 and a 1. Every time we hit F9, a 6 and a 3, 6 and a 6, a 2 and a 2, and so forth. Now we want the sum of the 2 die. So this equals sum, open parenthesis, and just highlight those two, B2 to C2, and hit enter. 2 and 6 is 8, hitting F9, 4 and 3 is 7. Oh, we did get a 7. 6 and 4 is 10, and so forth. Now we can take all three of these, go to the lower right hand corner and double click, and it will give us that for all 10,000 rolls. Notice that now, because we have headings in the first row, the last roll, the 10,000th roll, is in the 10,001st row of the spreadsheet. Now what we'd like to do is see the frequency of sum being equal to 7. So we can say, is the sum equal to 7? Just a text. We can find if the sum is equal to 7 by typing equals if the cell to the left of it, hit arrow left, is equal to 7. Notice the if function has 3 arguments: logical test, value of true, and a value of false. So the test is the cell to the left equals 7? And then we say comma a 1 if it's true, comma a 0 if it's false. In computer science and for these simulations we will use the traditional convention of 1 is a true and 0 is a false. Hit enter, and then we can see when it's a 7 it gives us a 1. Let's copy this down. And if we scroll down, everywhere we see a 7, there's a 1, and when it's not a 7, it's a 0. Now what we can do is count up all of the 1s. That's the frequency. Right here we'll go the relative frequency next. This is the frequency. So we're going to use the COUNTIF equals COUNTIF open parenthesis, in a particular range we see a certain number. The range is simply click on the E to get all of column E. Count if in the range you see a 1. Now in the lower left hand corner it's calculating, and it takes a while because it's rolling the die 10,000 times. It found it a 1 in this column, which means a 7 in this column, 1,687 times. That's how frequently it found it. And lastly, we'd like to know the relative frequency. Since we did the simulation 10,000 times, we'd like it to be the cell to the left divided by 10,000. We hit enter. It pauses for a while because in the lower left hand corner it's showing us that it's calculating the cells. And when it's done, it says it found a sum of 7, for instance here and here and here, 1,661 times. That's how frequently it found it. The relative frequency is 16.61%. Every time I hit F9, it calculates it again. And we can see that it doesn't stray very much from around 16%, somewhere between 16 and 17%. That's an estimate of the probability that if you roll 2 die, the sum will be 7.